So, what we're going to talk about today is we're going to talk about applications of the quadratic formula. So, when I look at that, applications mean word problems. So, it says a garden measuring 12 by 16 meters. So, I can look at that. Is to have a pedestrian pathway. So, they're going to put a sidewalk around it. All the way around, increasing the total area to 285 square meters. What I do know is length times width equals my area. So in this case, if I'm going to increase it, it's going to be increased by the exact same amount because it's going all the way around. I'm not going to make it wider length, wider width. It's going to be the same. So I'm going to start with a 12 plus x and a 16 plus x. When I multiply those two things, I'm going to get 285. So when I multiply two binomials like that, I'm going to go ahead and use FOIL. I don't know 12 by 16 off by heart, but it's 192. Now, I can solve this tons of different ways, but guess what I'm going to do? Probably complete the square because I think it's super cool. So when I complete the square, step one, I'm going to take the x squared and 28 and I'm going to flip them. I'm going to leave my space. I'm going to move the 192 over here. So it cancels out there. So 285 minus 192 is 93. When I complete the square, I forgot my x. I take 28, I divide by 2, I get 14. I square it, I get 196. I'm going to add 196 to both sides. When I do that, the whole reason I completed the square was to get x plus 14 squared equals 289. So now I am going to physically take the square root. When I take the square root, I get a plus or minus. The reason I do this is because 289 square rooted is pretty nice and easy. It gives me 17. I end up with x plus 14 equals plus or minus 17. So that gives me two problems. X plus 14 equals 17. X plus 14 equals negative 17. I subtract 14 on both sides. X equals negative 31 and x equals 3. Now, this is a word problem, which means both answers might not make sense. It's a parabola. I'm going to get two answers, but I got to figure out, is one of these things not working for me? Which one do you think it is and why? It's negative 31, but why? Because it's negative 31. If I plugged it back in, 12 plus negative 31 is going to give me a negative number. Can I have dimensions of a negative number? So that's why. It did ask me for my new dimensions. If x is 3, I'm going to add 3 to both of these. I get 19 and 15. So my new dimensions are 15 by 19. So take a second and write that down. So now that we have actually did it the long way, which I think is actually the short way, the even shorter way is going to be with the calculator. So if I open up Desmos, I'm going to plug in, and I'm sorry that I'm leaving all the writing here, but I want to be able to write it out. I am going to type in, and I'm not even going to do any real math. I'm going to type in parentheses 12 plus x, 16 plus x, enter. And what do I care about? Where y equals what? What does the original problem say? 285? So let me switch off this real quick. So you can see both of them. I can't see anything here, can you? Let's scoot it back. Oh, I found it. I want to go all the way up to what? Do you see how easy this is to change my window around? Where does this meet right here? So x equals 3 or x equals... Oh, wasn't that nice and easy? You can do that in the TI graphing calculator. You're going to have to do y1, y2, and then you're going to find where they intersect. So calculate intersection, but you're going to have to change your window until you can see it. Desmos, I think, is just like a click of a button, and I'm zooming in and out, and I can move stuff. So I prefer Desmos to stuff like that. But let's go ahead and go back and look at the next one. After t seconds, a ball is tossed in the air from ground level. It reaches the height in this equation right here. T minus 16t squared. So how can I figure out what is the height of the ball after 3 seconds? What am I going to do with that number 3? 4. T. T is time. Seconds is time. So 144 times 3 minus 16, 3 squared. I'm going to plug that into my calculator. And I get 288. So the next one says, what is the maximum height the ball will reach? You're looking for the highest point. That's probably going to be a vertex. So what's the vertex? HK, yeah. Now I could find that by doing what? I could find that by doing a couple things, graphing it and looking, right? I'm going to do it on Desmos. I could also complete the square if I wanted to. That also works. So let's go back to Desmos. I did that backwards. On Desmos, instead of this, I am going to have 144x minus 16x squared. And now what do I want it to equal? I don't care what it equals, do I? I'm looking for the vertex. Oh, I can actually see it right here. It actually happened to be pretty convenient. So if I look at this vertex, where is it? 4.5, 324. So let's go ahead and put that on there. .5, comma 324. That's my vertex. So what does that mean? The maximum height is 324 feet. Okay, so let's look at the last two problems. Find the number of seconds the ball is in the air when it reaches a height of 224. 144t minus 16t squared. 224 is not time, so I'm not going to plug it in for t. Instead, I'm going to set it equal to, because that tells me the height. Once again, I am going to go to Desmos for this. Clear out that one. I don't know why, I probably still needed it. And of course I use T instead of X. And it's equal to 224. So now that I have both of these on there, I'm going to scroll this down until I get to 224. Oh, it looks like it happens two places. 2 and 7. So 2 and 7. So if I go over here, what is T? Or 7 seconds. 2 and. That way you can see the difference. No. A U is when you're combining two intervals. A comma is when you're separating two values. I just put the word and because my comma, I didn't want you to think it was a decimal point. After how many seconds will the ball hit the ground? Well, if it's hitting the ground, where is it going to hit? How high is it? Yes, exactly. It equals 0. So if I go back to Desmos real quick, it is an and sign. I just didn't, when I put a comma and then it was looking like a decimal point, so I changed it to an and sign. Okay, so I'm going to go to 0. Almost there. Oh, found it. So here, 0, 0, that's where it starts. Time is 0. Where else does it hit? 9, 0. So after 9 seconds, it hits the ground. The other thing you must be able to do for this, which I'm not going to go over again, is plugging in the values and finding the quadratic regression. It asks you, it gives you a bunch of points. You have to plug it into L1, L2, hit stat, calculate, quadratic regression. So you guys should be good on that. So we're done. You have the rest of this class to do this packet.